Hello friends, welcome to follow up. Let's continue our problem solving. We are going to look at problem 508 in this video, most frequent subtree sum. And again, we are going to explain a solution based on recursion. So this problem is essentially the same in logic as problems 1120, 1973, 2265, right? So our plan will be the following. First, we are going to digest the problem requirements, and then we sketch the main idea, and finally we share the code. And also we want to point out the difference of this problem with the previous three problems. So now let's look at the problem. So given the root of a binary tree, we want to return the most frequent subtree sum. And if there is a tie, we can return all the values with the highest frequency in any order. So here, the subtree sum of a node is defined as the sum of all the node values formed by the subtree rooted at that node, inclusive. In other words, we want to include the node itself. So here we have two examples. So in the first example, if you look at the tree as a whole tree rooted at 5, the sum will be 5 plus 2 minus 3. That is 4, right? If you look at the two leaves, so their sum are just themselves. So we are going to have we are going to have 4, right? And then 2 and negative 3. So all of those appear once. So we return all of them. And in the second example, so if you look at the whole tree rooted at 5, so the sum will be 2 because the 5 and the negative 5 cancel each other. We get a 2. And then if you look at the leaf 2, we get another time 2. So 2 appears twice. And then we have negative 5 appears once. So we are going to return 2. And let's quickly look at the constraints. First, the number of nodes in the tree is in the range given by the closed interval 1 and 10 to the power 4. So 10 to the power 4 is a midi-large number, I guess. So, but if you consider square term complexity solution in leetcode, most likely you cannot pass all the test cases. So here the node value can be positive, can be 0, and can be negative, but they are bounded in absolute value by 10 to the power 5. So with that said, we are ready to look at the sketch of the logic. So this problem is very straightforward in logic, right? We need to traverse, and we want to find all the sums corresponding to each node or each subtree. And then there are 2 points come to be relevant. First, for each node, we need to get a sum of the tree rooted at that node, right? And secondly, we want to dynamically update the sum frequency, right? Because if we do the traversal, we get all those sums. So we don't want to do the traversal again and again to find the sum for each tree. So here for item 1, we can use recursion. So here we use recursion largely because of the fact that we are dealing with tree. And tree can be defined recursively. That's why when we look at problems involving tree, we can first think of recursion. And for the second item, so we can use dictionary. So here, for this problem, so we don't need to use attribute or local variable. The reason is dictionary in Python, for example, is a mutable object, right? So with that said, let's look at the coding part, which is actually very straightforward if you have followed the previous 3 videos. First, I'm going to initialize a dictionary, right? Dict. So you can also do something like this, right? If you like. That's just 2 different ways of initializing a empty dictionary. So now I want to write a hyperfunction. So given a node, so I want to retrieve the information given this node. I want to return the sum of the tree nodes for the tree rooted at the node. Inclusive, for example, I want just to emphasize this point. So because of the inclusive, we need to include node value, right? So because we are using recursion, first let's write a base case. In other words, if not node, so we're going to return 0, right? So then what we want to do, so we can do any outer traversal, right? So let's introduce a variable just for convenience. So we need to do, let's say, f node left. This makes sense first because we have already checked node left, because node is not if not none, we can always call node left or add node right. But even node left and node right are null, still they have value 0, right? So we can do something like this. So f node right, and because inclusive, we need to add node value itself. And then here, in general, we just need to return this L or this sum. Let's call it sum. It's more suggestive, total sum. So we can update the dictionary here. So we can do d of this sum. So we can use the get method. Get. So we want to check if this key as s as a key is inside dictionary or not. If not, we're going to assign a default value 0. And then we are going to increment by 1. Means that we match again s. So we do the return, right? So that's the main logic. So now if we want to work for this problem, we can think of this f as a worker to update this dictionary, right? Then we can do f root, call this function. But because it returns something, we can do something like this, but we just use it as dummy verb. So now we can first get the maximum frequency, right? The maximum frequency will be the max of d values. So in this problem, actually, we assume that we have at least one node. So this dictionary is not empty, right? So this will always valid. So if the dictionary is empty, we may need to assign a default value for the max function. So now we just need to use a list comprehension to return the sum, which corresponding to the maximum frequency. So here we can return it in any order. So just write sum, and for sum and frequency in the items, if this frequency equals the max frequency, right? So this basically finishes this coding. So now let's do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So that's basically about it for this problem. But let me slightly emphasize this point, because dictionary is mutable, so we don't need to use non-local variable in this case. So if you like, you can write this, right? Non-local and d, but it still works. This is the redundancy, because it's not necessary. Or you can do something like this, self d, and then comment this out, and then self d, and use it as an attribute, right? So here self d, let's see. All right. But it's not necessary, as I mentioned. So let's recover to its original format, right? So we can do this. The point is that this d used as a dictionary, so it's immutable. All right. So anyway, so yeah, that's basically about it for this specific problem and this video. So I would suggest that you look at this problem and the previous 3 problems together, so that you can observe the pattern. So with that said, that's it. Thank you.